Hi, and welcome to another quick tutorial on the features of Hasura Cloud that help handle a lot of the parts that are difficult, annoying, or complex to roll on your own. And in this case, we'll be looking at the cache directive inside of Hasura Cloud. Caching is always notoriously tricky with any sort of server on your own, and it's one of the three notorious problems listed. And in this case, we are able to implement that very quickly. What I want to first do is look at the query we are trying to cache. It is a reasonably complex query. We are doing a unison input filter on this list of images that have tags, that have confidence levels defined. We're doing a Boolean or a AND operator input here where we're saying give me all tags that have a confidence of 90 or greater, as well as where the tag names are in the array of berry or berries, as you can see listed here. It's a relatively complex query. It's going across multiple tables and it's giving us the results. I'm going to run this once, and what we're going to do is analyze the actual query that is generated, or the SQL statement being generated by Hasura from my database. I go to Analyze now. What we'll see is a relatively complex SQL statement. We have lots of ands, we have lots of nesting, we have lots of joins. Relatively complex. Obviously, Hasura abstracts all that away for us because it's a very nice API to work with. However, our performance is still not being benefited from the fact that Hasura is simply abstracting this to the most optimized query possible. We're going to fix that with Hasura Cloud today. So what we're going to do is switch actually to another window here, and I'm going to take us over to Postman, which is going to be our generalized API query interface for looking at some of these directives. So we'll switch to Postman now. So now we're going to come down to a cached query that we're going to go ahead and run again and see what results we get. Now I've run this one more time just before setting up our cached directive, and we can see that we have a slight improvement in our response time based on the warm up of my database and everything else. What I want to do is simply cache this now, and I'm going to do that by adding the @cached directive. When I add the @cached directive, it's going to run this through one more time, and we're getting a similar response as before, but now this is a cached response. And when I hit the request one more time, we'll see that we're drastically reducing our actual cache response time down to 170 milliseconds. So from our initial cold start from our database, which was around the 1100 mark, now down to 170 milliseconds, we've had a dramatic improvement in our response time. Even from our warmed up response, we've halved that with the @cache directive. Now Hasura's got a few more tricks up his sleeve to help you handle cache, because as we said, the caching is one of the difficult things that are stated. If we go to the a short cached query example here, we can actually define the time to live for that query by passing in a TTL argument on the @cache directive. Before I do that, I'm going to show you how to refresh the cache. There are two ways to do that. If we go back to our cached query, I'm going to run this one more time, and if I go to the headers, we'll see that in response we get the Hasura query cache key, and we also get a family cache key, and we can use those to pass into a cache clear endpoint to clear that specific cache. We can do a forced cache clear where we can actually access this /pro/cache/clear, which will clear all caches. We can also use a cache refresh where we pass in a refreshed token here. I'm going to go ahead and clear all the cache, and that's just going to wipe out all of my caches. And when I come back to this short cache query now, which has the TTL of 5 seconds, this is always defined in seconds. I need to grab my query here actually and go to the short-lived, and we'll switch this to the cached TTL of 5. We'll see that we get that initial response back. So if we look at the query here, 167, 160, 161, 161, and we can see that that 5-second mark is being reset roughly every 5 seconds. Let's go ahead and look at what a long-lived cache would look like. We're going to go ahead and copy this, move to our long-lived cache, and we're going to define this to the cache length maximum, which is 300 seconds. And when I run this now, we'll see that with each subsequent request, if we go to the headers, which tells us how long that cache has to live for, if we look at the cache control header here, that'll tell us the remaining amount of times, 235. We run that again, 229, and we can see that that is slowly decrementing as we go. We'll refresh that cache one more time by passing in the refresh true, and we see that we get back an uncached version of that response. If we go to the clear and we go ahead and actually just clear out the caches entirely, again, we reset it completely. If we go back over to the Hasura console, we can actually inspect some of this behavior. And if I switch to the monitoring tab here and I go to my operations, we can see some of the performance gains that we've gotten from this berry picker query. We can see the differences between the unoptimized cache time and the cached response time. If I go to the next page here, so here was one of the original unoptimized cache requests. The execution time took 85 milliseconds, and we can see that the execution time took only 3 milliseconds, as opposed to then just the round trip that I was seeing in my response times. We can do this very transparently. If we go back to our API query, we'll go ahead and run this one more time. We've cleared that cache before, so there's going to be no cache responses here. Let's go to the monitoring tab to view what we are now seeing. So here are some unoptimized requests for that berry picker query, 93 milliseconds execution time. If I head back over now to the API Explorer and I pass in that @cache directive here, and I go ahead and I run this, what we're going to see is that the optimization of that operation time is pretty dramatic. So if we go back to operations, we'll see that we went from the 106 execution time to now down to 2.35 milliseconds. So a rather dramatic speed up and performance optimization using the cache directives without any extra effort other than simply renaming our query with the @cache directive on there. For more information on the caching specifically, go ahead and check out our documentation. If you have more questions about Hasura Cloud, contact us in any of our community platforms, watch our YouTube videos, and if not, we'll see you at one of our future webinars. Thanks. Bye.